Hello everyone, very warm welcome to all of you on the platform of FT+. My name is Akhilesh and we are meeting here for geography preparation for your UPSC and state PCS examination. In today's topic, as I told you in the next video, we are going to discuss about jet stream, genesis of jet stream and how this jet stream is playing pivotal role in deciding the upper atmospheric circulation as well as the entire weather phenomena, which is quite intrinsic and related with jet streams. So, as I told you in the last class, these are the air masses which is going to be left in the upper atmosphere near tropopause. So, let me explain this near tropopause situation. As I told you that near tropopause you are going to have a lid like structure. This is called as tropopause. It is not kind of structure, it is kind of limit. So, this is called as tropopause and this is the end of troposphere. You all have this idea and it acts as lid, and this area is going to have equator and this is going to have pole. Fine. And here the height of tropopause is going to be almost 18 kilometer, while it is just 8 kilometer over the pole area. And I told you that some air mass was left over near the equatorial low pressure belt, because there was convergence of air and rising air left some air mass, and there is some air mass which is left over near subpolar high pressure belt. Fine. So, these were the air mass which is left over air mass, and this leftover air mass, how it is going to constitute jet stream, let me explain that. Fine. So, jet streams are upper atmospheric fast moving voluminous air currents that is responsible for many weather phenomena, and it is moving in upper atmosphere between 9 to 12 kilometer of height. And you all have idea that these jet streams were discovered at the time of Second World War, when the bombers were going towards USA and they are coming back, and meanwhile they find that one way they get facilitated by the wind movement, and when they are returning back they get opposed by the wind speed, upper atmospheric circulation, and that circulation have very high speed of more than 120 kilometer per hour. So, this is called as jet streams. Fine, but these jet stream, how they are produced, what are the reason of this genesis is going to be discussed in this particular video. So, be and get tuned with it. Fine. So, there is a air mass which is left over. This is the air mass which is left over when there is rising of air current at equatorial region. And as you know that in upper region at equator you are going to have high pressure. There will be high pressure developed over here, high pressure because of rising of the air. This is a lid, and here it is rising of air. So, rising of air will press this area, creating high pressure in upper atmosphere. Do remember, okay, high pressure in upper atmosphere near tropopause, near equator, just above equator you will find high pressure over here. Fine, because there is voluminous condition, the air is rising up because anything cannot go beyond this lid. That is why there is high pressure developed just above the equator. And in second case, if you see this polar area, you will find that air is sinking. So, air is sinking, and if you are here, this is the lid, so there will be vacuuminous condition. So, here you are going to have low pressure that is developed in the polar area. So, try to see in upper atmosphere, tropopause ke paas the gradient, kind of gradient which is developed. So, the gradient is from high pressure to low pressure. This is what the gradient, pressure gradient. That means the PGF, pressure gradient force, is directing the movement of wind from equator to pole. Fine. In upper atmosphere, one pressure is lagging, that is frictional pressure. There are three pressure, one is PGF, pressure gradient force, another one is Coriolis force, and the third force which is responsible for movement of a wind or wind system is frictional force. Frictional force is simple, the friction that is between the wind as well as the surface. If the wind is near earth's surface, there will be high frictional force, and this high frictional force will do what? It will restrict the flow of the wind, fine. But if it is absent, so only two forces are there, and one is PGF, another one is Coriolis force. So what happened? This wind mass start moving, air mass start moving from high pressure to low pressure, and they start moving like this. But what happened? Can they move like this? Answer is no. Why? Because Uncle Ferrell will reach over there and say, no, 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 this is not the way to move. In Northern Hemisphere, if you move somewhere horizontally, there will be Coriolis force, the pseudo force, the frictional drag which move you in which direction? Which deflect you in the right direction if you are moving in Northern Hemisphere, and in left direction when you are moving in Southern Hemisphere. So try to see, this wind start moving like this, but start turning towards your side. Try to see my hand, it start moving like this, but it will turn towards right, it will turn towards right. Try to see, it will turn towards right and start moving parallel with the isobars, and this is called as geostrophic wind. And if it start moving like this, so tell me, if it is the earth, so it will start moving from west to east, and this is what? Genesis of subtropical westerly jet stream, genesis of subtropical westerly jet stream. And likewise, this jet stream, this air mass start moving along the PGF, but what happened? Again Coriolis force will say, okay, get deflected towards your right, because Coriolis force and PGF managed in a way that wind start blowing parallel with isobar, and we call it geostrophic wind. So you will find that there is a genesis of one jet stream near subpolar region, another near subtropical region, and these two jet streams are called as global jet streams, and they are moving in that direction. Let me show you those jet streams, like how they are moving. So you will find that there is a jet stream which is called as a tropical jet. It is moving like this, and polar jet, it is moving like this, fine. So they are not moving in a straight line, they are moving, they are meandering and moving from, blowing from west to east throughout the globe. This is called as subtropical westerly jet stream. It is global in nature, throughout the earth it is blowing, and this is called as polar jet. Again it is also blowing from west to east, and this is also going to be global, fine. So these are the jet streams, and they are not moving in a straight line, they are meandering, and this meandering is because of Coriolis force, because of pressure gradient force, because of buoyancy force, as well as there is some force responsible for vertical meandering, there is some force responsible for horizontal meandering. So in this case you will find there is vertical as well as horizontal meandering. So in upper atmosphere the jet stream is not moving in horizontal meandering, but it is also going for vertical meandering. So in that way it creates a shear wall of omega shaped shear wall, and this omega shaped shear wall sometime means trap an air mass. Suppose that it traps a cold air mass or warm air mass in the area which happen to be colder region, So this warm air mass is going to be trapped over here. So this is warm air mass. So obviously in cold area, if the warm air mass is just above the head, it will create heat waves. So it will create heat waves here. Fine. And suppose that if this jet stream brings some cold air mass in area which happen to be subtropical, or you can say happen to be subtemperate area, and there is cold air mass, very cold air mass brought over here. This is cold air mass. So obviously it will bring cold, that is cold waves, cold waves. So heat waves and cold waves, they happen to be the outcome of the meandering of the jet stream, because this meandering creates omega, and this omega is creating a shear wall. These are Rossby waves basically, and this shear wall is going to trap either warm air mass, maybe cold air mass, and causing respective heat waves. So nowadays these heat wave phenomena are on increase, and that is attributed to global warming. Why? The temperature is going to change, it is going to rise. So if temperature is going to rise, obviously these jet streams get strengthened. If jet stream get strengthened, they will go for more meandering. If they are going for more meandering, so more trapping of such phenomena will take place. So there will be rise event of cold waves and heat waves nowadays, and in coming days also it is attributed to global warming. I hope you understand. If not, so we are in the class going for the detailed studies. Thank you very much for today.